Hi everyone, my name is Aradhya and my teammate name is Darshan Nayaka. Now we are usually talking about Dragonfly optimization algorithm, which is comes under the natural inspired computing subject. So let's talk about some introduction. Like Dragonfly algorithm is usually developed by some scientist name called Mirza Lili in 2016 actually. It is usually found in Japan actually. Like Dragonfly is a symbol of the strength, courage, and happiness in Japan, and it is a meta heuristic algorithm. It is usually inspired by the behavior of the dragonflies in nature, because the dragonfly can move in such a way that it can come straight down and straight upward direction, and it also can move in the form of helicopter, helicopter also, as you all can see in this picture also. Next we will talk about some characteristics and properties of dragonfly optimization algorithm. Usually dragonfly, it has some large magnified eyes and transparent fancy wings, as all can see here. Uh, After that, it also has some elongated body actually. Like one dragonfly can survive for the at least 6 months actually. It has a wingspan will be in 750 to 30 750 mm or 30 inches. And also, one dragonfly can survive in such a way that it has to consume some food actually. It usually consuming the food called like mosquitoes, like 30 to 100 per day, and it can move in a speed of 30 miles per hour actually. And in Dragonfly algorithm, as I already told about, it's a meta-heuristic algorithm. It is usually inspired by the static and dynamic behavior of the dragonflies. In static behavior, the feeding swarm is a concept, and in dynamic behavior, migration is the concept actually. Uh, in static swarm, it's usually one dragonfly can make some small kind of groups. After that, it is move in a particular direction which has to move actually. After that, it usually searching for his food, like mosquitoes and mosquito and small kind of insects actually. In dynamic behavior, if I want to explain, like in dynamic behavior, it's forming the dynamic swarm. Like it usually creating some larger number of dragonfly groups. Then it usually migrate from one place to another, whatever direction it wants to move in such a way. After that, it also finds some food for its survival. Let's usually talk about the dragonfly algorithm, how it actually works. As in many of the algorithm, we should initializing some population randomly. After that, we have to initializing some step vector and size of for the dragonfly also. Then we usually moving the some iteration like while loop, or you can also use the for loop also. Like what can we say? Like current iteration usually, which if is less than the maximum iteration, then loop has to be updated again and again. And usually in computer fitness value for each dragonfly, we have to compute the fitness value. Like fitness value means it's a fitness function actually, in the form of normal mathematical functions like f of x only. Then updating the food source and enemy, and updating the parameters like w, s, a, f, all the things, and updating the neighbor radius also. If I want to explain this algorithm, let's continue. Yeah, first step is usually nothing but initializing the population. Here we usually initialize the population to 25 actually, n is equal to, and initializing the population, and after that we should go the initializing the position for each dragonfly. Using this formula, we have to generate it using the random function using the numpy also. And yeah, step 2 is nothing but once we initializing the population, we have to give the some current iteration and maximum iteration, how much iteration our algorithm should go. uh if yeah, while one value, actually current iteration is 1, maximum iteration is 200, absolute it is a true, then it will comes under the iteration or while loop. Then whatever the statement which is inside that particular while loop, it usually executes actually. Okay, next we have to computing the fitness values for each dragonfly. We like individual dragonflies. Using the fitness function, we have to compute the fitness value for each dragonfly. Next, we should go for the dragonfly algorithm, like step 4 actually. It's nothing but after once we computing the fitness value, then dragonfly also has some advantages and disadvantages. How it actually searches the food and how it is actually escape from the enemies. Yeah, where we have to update that particular concepts also, like updating the foods as enemy. After that, this concept will be explained by my teammate Darshan actually.
So now I'll be talking about the coming steps. So here we basically going back to the back slide. So here we basically calculate the neighborhood radius. So this is just a way of checking how many dragonflies are close to each other. So basically after we evaluate all the dragonflies, we look at their performance, such as if there is a food source, then the dragonfly has found the best position. Or if there is an enemy, then the dragonfly that has found the worst position. So why do we do this? Because in the dragonfly algorithm, the dragonflies behaves just like they do in the nature. So they naturally move towards the food and avoid enemies. So once we identify who is the best and worst, other fly uses this information to adjust its direction towards the best position. So now going on to the next slide. So we have two expressions here. So we have two expressions here, which is the food and the enemy. So the first expression, which denotes that food position is equals to food source position minus individual current position. So this expression, it basically says that the dragonfly to move in the direction of the best solution. As I told earlier, the best position is the food source position. So this is the expression which denotes the dragonfly to move in the right direction. And the below expression, which is an enemy expression, so this formula basically pushes the dragonfly away from the worst solution. So now let's go on to the next slide. So next step is updating the parameters. So we have different parameters such as W is for inertia weight. So this basically means that so this controls how much of the previous momentum has been carried in the current position. So the next is called as a separation weight, which is denoted by S letter. So this avoids the dragonflies to avoid colliding with other dragonflies in the same swarm. So A is equals to alignment weight. So this controls how strong the dragonflies try to match the direction of the other neighbors. So this is denoted by letter small a. So next is the food attraction weight. So food attraction basically tells how strongly the dragonflies should move towards the food source. Similarly, E denotes the how strongly the dragonfly should move away from the enemy. And then we have three important principles which are known as separation, alignment, and cohesion. So going on to the next slide, which is the continuation of the three important principles. So basically, separation means that it avoids bumping into other dragonflies. So this is basically separation means. Whereas alignment, so it tries to match its direction and speed with its neighbors. Whereas cohesion, it tends to move towards the center of the swarm to stay in the same group. So these are the main and the important principles of the dragonfly algorithm. So the next step we have calculating SAC. Basically, as I told earlier, S for separation, A for alignment, and C for cohesion. So we have two different expressions stated here. For the first expression, let's see, which is SI, which is denoted for the position of current individual. So here, X denotes the position of the current individual, whereas XJ denotes the position of its neighbors. So we can observe that. So here we can observe that there is a minus sign. So this minus sign basically means that it pushes the dragonfly away from the neighbors. So going on to the next expression, we have AI, which is nothing but the alignment, which is the important principle of the dragonfly algorithm. And here it denotes the summation of VJ. So VJ basically means that velocity of each neighbors. So the neighbor of the each dragonfly. And CI, we have this expression, which is the position of the neighboring individual. So going on to the next step, we have this is same as explained earlier. So the next slide is that. So yeah, we can observe here that so the this is the important algorithm. So first we need to update the neighboring radius and we need to check the neighboring of the dragonfly. So if there is any neighboring of the dragonfly, we need to update velocity and position. So if there is neighbor and if there is no neighbor, then we have to check the other neighbor by doing a random walk. So yeah, as I told earlier, if there is a neighbor, we have to update velocity and position, and if there is no neighbor, we have to do a random walk. Going on to the next step. So yeah, so this is a mathematical expression for calculating step vector calculation. And the next slide shows that the expression. So let's go on to the next slide. So yeah, this expression where we can observe that t plus 1. So this expression shows how random walk can be done if there is no neighbor near to the dragonfly. So this is basically concludes the dragonfly algorithm, which explains the nature of the dragonfly, which is inspired by the nature. And yeah, this explain all about the dragonfly algorithm. Thank you.
Thank you.